Now we will learn how to find the volume and surface area of a torus. A torus is a donut shaped circular cylinder. That means if we imagine that we have a cylinder and we bend it in a circular fashion, keeping inside a circular hole, that is just like a car's tube. So this torus is made out of a cylinder, where a cylinder is bent circularly to give a donut shape. So then that 3D object is called a torus. So the torus dimensions is represented by the radius of its outer edge, that is from center to this radius, this big large radius, and the radius of the tube, that is the cylinder, radius of the cylinder that is bent into a circular donut shape. So these two dimensions, if we are given these two dimensions, then we can calculate the surface area and volume of this object. So to calculate total surface area and volume, let us unfold it. That means let us unfold it to its original cylindrical shape. So what will happen if we just cut from here? Then it will be a R radius cylinder, and the length of the cylinder will be this total length, which is the circumference of this outer edge. This radius is R, so this circumference will be 2 pi r. So if we cut it here and unfold this total cylinder, then this torus shape object will be a cylinder where these two edges, these two faces will be hole. That is, there is no surface here. So these are holes. This is one hole, this is one hole. So there will be no circular face here. This is just a hole, and this will be a cylinder. So now this is an R radius cylinder, and this length of this cylinder, that is the height of this cylinder, is 2 pi r. 2 pi this capital R. So now from here we need to calculate the volume and surface area. Again, for a cylinder, if we just consider this as a cylinder, and if we cut its edge, so this curved surface, because there is no circular surface at two ends, this, because we cut it from the middle, so these two ends are whole. So only this circular, that is the curved surface, is giving the surface area. So if we cut in the middle and make it a rectangular shape, then this length 2 pi r will remain as it is, and this, if we start from here, we come round, that is a circle circumference. So this edge will be circumference of the circle, which is 2 pi r. So first we cut this torus from here, make it a cylinder, and then we cut this cylinder edge and straighten it up as a rectangular face. And this rectangular faces, one dimension is 2 pi r, another dimension is 2 pi capital R, where the capital R is the radius from the center to the outer edge, and small r is the radius of this cylindrical tubes from center to outer edge. So this is the radius of this cylindrical tube, and this is the radius of this total donut shapes center to outer edge. Then the total surface area is this rectangular area. So the TSA, the total surface area, will be, so this is a rectangle, these two dimensions multiplication. So it will be 2 pi r times 2 pi capital R. So it will be 4, pi and pi will be pi square, and then small r and capital R, small r and capital R. So if we are given these two radius, we can find total surface area using this formula. Now the volume. So the total volume of this torus will be the volume of this cylinder, where the cylinders, we know that if we have a cylinder, with radius r and this height h, then its volume is pi r square h. This is the cylinder's volume formula. Now here, for this cylinder, this radius is r, and this height, that is this length, is, this is the height, so h is 2 pi r. So the volume will be, V will be pi r square h, that means pi r square. This radius is smaller, so this base area is pi r square, and this total height, that is length, is 2 pi capital R. So pi r square times h, where h is 2 pi r. 2 pi r. So from here we will be getting volume equals to pi and pi square, small r square, and capital R. So this is the formula for finding the volume of this torus, and this is the formula to find the total surface area of this torus.